Welcome you all for today's discussion. आज हम we will discuss about concentrating collector. This is a new topic. Earlier we have discussed in module 1 about flat pay solar collectors, its application, temperature range that we can achieve, why it is not called a concentrating collector, and how we can even make a flat pay collector by using reflector to make it a concentrating collector. Basic difference, we already know that what is the difference between flat pay solar collector and concentrating. In non-concentrating type collectors, these collectors can use both type of solar radiation, means diffuse radiation and direct beam radiation. Direct beam radiations come directly without any interference from the atmospheric cloud or dust particle or rain particles, but and reflection from the ground. But concentrating collectors use only direct beam radiation because these are focusing types of the focusing type of collector, either based on the reflection from the mirror or from the lens. Only two ways we can concentrate, either reflection or by using lens. So here we are going to discuss about concentrating collectors, and in concentrating collectors one of the most important one is a cylindrical parabolic concentrating collectors, and concentrating collectors are used for the developing very high temperature that can be used for the running of power plant, thermal power plant. And thermal power plant means we can use concentrating collector to run steam turbine by producing steam, and that steam can be used for the running of steam turbine and generation of electric power. So that is the main purpose of the concentrating collector, to produce to use thermal energy from the sunbeam radiation and produce steam, and that steam can be used for the generation of electric power. So that is a basic difference. But non-concentrating collector only produce heat energy. That heat energy can be used for the water heating, that and for process heating in chemical industries and milk pasteurization and pulp and paper industries. And so low temperature heat can be generally used produced by the non-concentrating type of collector. So here we are going to discuss concentrating collectors. So first we discuss basic of the concentrating collectors. Concentrating collectors. Concentrating collectors. Basic definitions. Basic definitions. Suppose let us draw one line drawing here. This is a collector, concentrating collector, parabolic, cylindrical parabolic type, and there is a tube, and radiations are coming like this. This is very simple drawing, and radiations are coming like this, and focusing here, radiation are coming like this, and this is a width of this collector is W, and length is L. This is a simple diagram, parabolic cylindrical, and this is a tube through which fluid is flowing. This is a tube through which fluid is flowing. And if we can use a concentric surface also here. We can use concentric tube, and so that radiation. This is a one just to explain how this can be looked. This is cylindrical parabolic collector, and here we have to define number one, aperture. Aperture is nothing but it is opening. Aperture means opening. Aperture generally आप देखा होगा कि aperture जैसे lens aperture. Opening of the lens, opening of the this face. It may be cylindrical, it may be spherical, it may be circular area, it may be rectangular area. So opening through which radiation coming, incident radiation coming to the surface. So higher the opening, higher will be the incident radiation coming to the surface. This is known as just opening of the collector surface, opening of the collector face through which incident radiation comes to the surface. Means जो opening होती है उसी से incident, अगर opening नहीं हुए तो radiation ही नहीं आएगा. This is known as aperture. Number 2. Second one is let us reduce size. Reduce its size. So now reducing size. Next one is intercepting area. Yeah, angular acceptance. Number 2. This is also important. Angle of acceptance. This is the maximum angle, generally defined by 2 theta. 2 theta A. Angle of acceptance means suppose the normal position is this one. This is normal position on the surface, and this angle and this angle, two angle, 2 theta alpha and 2 theta alpha means maximum angle both side to the normal that will be accepted by the surface of the collector. Means up to this angle, if radiation will come, it will be accepted. Otherwise, if more angle will be more, it cannot be focused on the observer. It cannot be focused on the observer surface. This is the maximum permissible angle, normal, both sides to the normal, up to which if radiations are incident either from here, that radiation can be focused on the observer surface. Otherwise, if angle is more, suppose angle is like this, angle become more, then it will not be reflected back to the observer surface. So this is the maximum angle, that's known as a angle of acceptance. मतलब कि नॉर्मल से दोनों तरफ वो मैक्सिमम एंगल होता है, इसलिए हमने 2 थीटा ए से डिफाइन किया इसको, 2 थीटा ए या 2 थीटा अल्फा, एनी वे यू कैन डिफाइन, but it is a maximum permissible limit normal to the incident radiation, normal to the surface, up to which if radiations are coming on the surface can be focused on the observer tube. That is known as a angle of acceptance. Number three, one that definition is also very important. Angle, intercepting angle, intercepting factor, angle नहीं होता है, intercepting factor, gamma I intercepting factor, gamma intercept. So intercepting, if this is surface that is reflect the incoming radiation to the observer surface. The total is not intercepted by the observer surface. Means this from here reflected back to the observer surface, but total 100% is not. So fraction of the reflected radiation which can be intercepted by the, which are reaching to the observer surface is known as a intercepting factor, maximum fraction. So fraction, it is known as a fraction of incident radiation reflected from the collector to observer surface. So fraction of incident radiation reflected from the collector to the observer surface, that is a reaching, means reflected fraction of the reflected beam radiation reaching to the observer surface, that is known as a intercepting factor. जनरली जो वैल्यू होती है गामा इंटरसेप्ट की, वो होती है अप्रॉक्सीमेटली 98 to 99%. मतलब कि जो रिफ्लेक्शन यहाँ से हो रहा है ऑब्जर्वर, मतलब कलेक्टर सरफेस जो रिफ्लेक्शन हो रहा है ऑब्जर्वर सरफेस पर जा रहा है, उसका 98 to 98% ये यहाँ पर एक्सेप्ट हो जाएगा, 98% तक फोकस हो जाएगा. दैट इज नोन एज ए intercepting factor. And next one is a most important factor is a collector concentration ratio, concentration ratio, CR, collector concentration ratio. This is most important because everything, very efficiency of the collector depend upon the concentrating factor, CR, concentration ratio, concentration ratio. Higher the concentration ratio, higher will be temperature achieved by the collector. So collector temperature depend upon the collector concentration ratio. Concentration ratio means if concentration ratio is suppose 10. So means incident beam radiation intensity multiplied 10 times. If concentration ratio is 100, intensity of the sun beam radiation will be multiplied by 100. That is a purpose of the concentration ratio. So concentration ratio can be defined as effective area of the collector surface to area of the observer surface. So suppose here we are seeing here we are taking example of the cylindrical parabolic collector. This is a cylindrical parabolic collector, and this is a width W is a width of this parabolic, and here is a tube, cylindrical tube, concentric cylindrical tube. Outer diameter is a D0, and here, and if अगर इसका लेंथ है, टोटल लेंथ कितना है, L है. So area, effective area of the collector, because when rays are coming, so it will create image. It will create image. It will create image here like this. So this area is in overlapped area. This area is overlapped area. This area we have to reduce from active area, effective area. So this area will become W into L minus D naught into L. D naught L is a effective area. When we make projection on surface, then total area of the collector will become W into width and length of the cylindrical parabolic, and we are reducing D naught into L. So D naught L is a strip of the area, that is a shadow area, because shadow of this tube will fall on the collector surface. So up to this area, radiation are not, direct beam radiation are not reaching. That's why we are subtracting D naught into L area upon area of the collector surface, area of the observer surface, pi D naught. Pi D naught is circumferential area, circumference into pi D naught L. Pi D naught L is circumferential area of the observer tube. Circumferential area of the observer tube is pi 2 pi r. We know 2 pi r. So pi D naught L. Pi D naught L. L is the length of tube, length of the collector surface, collector. So here take common L, common W minus D naught upon pi D naught L. So L is cancelled. So W minus D naught upon pi D naught. This is a concentration ratio. This is a way of finding out concentration ratio. Another definitions are there: reflectivity of the observer, because 100% reflection is not. Some portion is absorbed by the collector surface, some radiation is absorbed. So reflectivity is a reflected radiation from the reflectivity is also there. We will define reflectivity of the surface. So this is a characteristic of the collector reflect. It is just a reflector. So characteristic of the surface, highly polished surface. That's why we use highly polished surface, so that we can achieve approximately 100% reflect, but it is never 100%. You can see 99.9% reflectivity. मतलब कि radiations coming on the surface is reflected anywhere. It means either reaching up to observer surface or not, but it will be reflected. It will not absorb. So 99.9% radiations, that beam radiations coming on the surface of the collector are reflected, but it is not guaranteed that reflected beam radiation reaching to the observers. ये मतलब गारंटी नहीं है, बट रिफ्लेक्ट, इसको रिफ्लेक्ट करना है, आपको अपने पास नहीं रखना है, ऑब्जर्व नहीं करना है. इसका काम है रिफ्लेक्टर, काम रिफ्लेक्ट करना है. फोकस कर रहा है नहीं कर रहा है, इट इज डिपेंड अपॉन अरेंजमेंट, अलाइनमेंट ऑफ द फोकस. अगर ये लाइन प्रॉपर्ली अलाइन नहीं है, ऑब्जर्वर सरफेस प्रॉपर्ली अलाइन नहीं है, तो वो उस पर फोकस नहीं हो पाएगा. तो पहले हम फोकस अलाइन करते हैं. जब फोकस प्रॉपर्ली अलाइन हो जाएगा, तो एनी रिफ्लेक्शन कमिंग अप टू द एक्सेप्टेंस एंगल will be reflected, will be captured by the observer. So this is all definitions about concentrating collector. So that will be used in analyzing collector efficiency factor and collector heat removal factor, that we are going to discuss just after this definition. So thank you very much for this discussion. This will be used in defining collector efficiency factor and collector heat removal factor. And just after this lecture, we continue to discuss collector heat removal factor and collector efficiency factor, which are very important parameter for designing a concentrating collector and further improvement of the performance of concentrating collectors. These are parameters which are cardinal in defining the thermal performance of the concentrating collectors. Thank you very much, and please continue after some time.